Hey everybody, welcome to Geometry Basics number 6. The two formulas that I absolutely hate, that I don't know why people use them. I don't know why these formulas exist. I feel like we just scare kids, and I don't know why. Let me explain what I mean. So we have the distance formula here, and we have the midpoint formula. Those were not included on your notes. You need to write them down. And the reason these formulas drive me crazy is because we take things that should be common sense. We take things that kids should actually know because they have basic skills in other areas, and then we just put a formula to it instead. Then when kids use common sense, we tell them they're wrong because they didn't do it our way. I hate it. I can't stand it. So today we're going to try to be a little bit different. So there's my 1-minute rant, and we'll get going. So we're going to go through these examples, and in each example, we're going to find distance and midpoint between 2 points. Midpoint we've already dealt with when it comes to segments. We talk about how if there is a midpoint given to us, the midpoint breaks up a segment into 2 equal pieces. So we do have some significance there. So it's good to practice how this looks on a coordinate plane. So there's our example number 1. We're going from -3, 7 to -3, -5. Now again, I told you, here are the formulas. I do want you to write them down, and then I just never want you to speak of them again because they don't really build our sense of how math should work. Besides, if you want to know the distance and you don't actually want to use a formula, there are graphing calculators like Desmos online that'll do it for you anyway. So long story short, I'm going to talk about it from a completely different perspective. So here we go. We're going to go from -3, 7 to -3, -5. We're going to talk about distance. We're going to talk about midpoint. Now if what you've created is directly horizontal or directly vertical, then you don't actually need to use a formula. All you have to do is count some squares. So you start figuring out, well, if I were to go from 7 to -5 along the y-axis, then that means I traveled a total of 12 units. So you just say the distance is 12. When we're talking about a coordinate plane, we don't really need to do anything more than that. No label at this point. Now, when it comes to midpoint, the formula tells us to add the x's and then divide by 2, and then add the y's and divide by 2. If you look at the formula, it's pretty clear about that. I don't understand why the formula exists because we know what to do when we add and divide by 2. We know what's actually happening. If you get a 60 on one test and an 80 on the other, and you want to know what your average was, you could add the 60 and the 80 and then divide by 2 because you took 2 tests. That's exactly what's going on here. That's all we're doing. The midpoint is going to be what happens if you add and divide by 2. In this case, you don't really need to do the average of -3 and -3 because it's the same value. It didn't change. So the average of -3 and -3 is, well, -3. Now, when it comes to the y value of your midpoint, add and divide by 2. 7 and -5 make 2, and then cut that in half, and you get 1. If you were to graph that, sometimes it's good just to put that dot down just to double check and make sure you feel pretty good about what you did. And that looks good to me. All right, now we're going to go to example number 2 here, and we're going to go from 2, 4 to -4, -4. So now we're going to get a little bit trickier, which isn't that big of a deal. It's not that tricky, but it's good to draw it out. Now, distance will not be as obvious this time because this time it is not directly horizontal or directly vertical. But since it's drawn out for us, instead of using a big long formula that you don't have memorized, why don't we use a shorter formula that you do have memorized? What I want you to do here is take that line that we just created, that distance that we're trying to come up with, and draw a right triangle using it. So the distance that we want is going to be right here. The reason I suggest you do that is because now that it's a right triangle, we can say a squared plus b squared equals c squared. We can build on the Pythagorean theorem, which is something that you learned back in the day, and you definitely covered in Algebra 1 without a doubt. So basically, instead of taking something new, a formula that we don't want to deal with, we can just use a formula that we already know instead. Now I bring that up because here it comes out pretty nicely. 6 squared. So basically I counted squares and I said 1, 2, 3, 4, 5, 6. Plus, and I count more squares, and I'm going to say that's 8. So 6 squared plus 8 squared equals c squared. Now, in this case, c is the hypotenuse, but it's also the distance. You know, the reason we talk about this in the first place is because the hypotenuse is the distance that we're looking to find. So we break out 6 squared, which is 36, 8 squared, which is 64, and if you add those together, you get 100. All right, so then you just have to figure out, well, what number squared gives you 100? And that would be 10, which means the distance is 10. Now, when it comes to the midpoint, again, this should be a mental math activity. It shouldn't be that complicated. We're just going to take the average of the x's, the average of the y's. Don't do a formula. Don't think about it that way. Don't scare yourself. Just average of the x's, average of the y's. So the average of positive 2 and negative 4. So we're just looking at the x's first. If you were to add 2 and negative 4, you would get negative 2. Divide by 2 and you get negative 1. So the midpoint would be at negative 1. And then the average of 4 negative 4 is actually 0, because if you add them up, you get 0. So just to test, make sure we're good, draw that there. And that checks out really nicely. So let's go with it. All right, remember, if I go too fast, you can always pause it and go back. So example number 3 here, we are going to go from 6, 4. I'll go back to my original color here. We're going to go from 6, 4 to negative 2, 3. Now this one, you'll notice once we get going on it, that it does not come out perfectly nice. It does not come out to a whole number for a distance. It will come out to an irrational number. It's going to be a decimal. And let me explain why. So the distance that we're looking for is from here to here. And the right triangle that we're going to draw to try to make sense of it all is actually really, really skinny here. We only have 1 unit there, although we have 8 units here. So if we're going to set up the Pythagorean theorem here, it's going to look a little bit weird. It's going to be 8 squared plus 1 squared equals c squared. 8 squared is 64. 1 squared is still 1. So this is a good example to practice because it did not come out quite how we anticipated. Now, depending on your teacher, depending on what they're looking for, sometimes they're going to show it as a decimal. What number squared is 65? Well, 8 squared is 64, so it makes sense that this would be just a teeny bit more than 8. Sometimes you will see a teacher that wants it written as a radical, and you're going to leave it as the square root of 65. It doesn't really matter to me personally. I would take either one if it were me. Now I'm running out of room, so I'm going to have to cram this in here. Midpoint would be the average of the x's, average of the y's, same thing as we've been doing. The average of 6 and negative 2, you add and divide by 2, you get 4 divided by 2 is 2. And then the average of 3 and 4 would be halfway in between. That'd be 3.5 or 7 over 2 if you are a fraction person. I like putting the dot here just to verify that we get what's going on. And 3.5 would be right there. And sure enough, that is the midpoint. All right, we go to example number 4 here. And now we're going from negative 6, 5 to 6, 0. Okay, so we're going to put these 2 points down. Again, the visual, even though you don't necessarily need to draw it out, and in fact, in our last couple examples, we won't, the visual is still really helpful. So hopefully just seeing it on a coordinate plane helps you get a game plan. Now, it doesn't actually matter which side you draw the right triangle on. You could have drawn it a different way entirely, and you would have been just fine. Because really, we're just using it as a guide. We're using it to count squares. And so we say from -6 to 6, that's a distance of 12. And that's a distance of 5. Oh, I made this one too easy. Take a look. So here we go. You got 12 squared plus 5 squared equals c squared. If you take 12 squared, which is 144, and 5 squared, which is 25, and you add them, you get that. And what do you know? I made it too easy. The distance is 13. You might not have known that, but 169 is a perfect square, so the distance is 13. Now, as far as midpoint is concerned, once again, if you average -6 and 6, you get 0. So the x value of your midpoint is 0. The y value, the average of 0 and 5, well, 5 plus 0 is 0. You divide it by 2, you get 2.5. Or if you are a fraction person, you could have called that 5 over 2, just like you could have called your midpoint over here 7 over 2, depending on that, if you like it that way or not. So we go to 0 and 2.5 on our graph just to double check. Desmos actually does that as well. You ask it for the midpoint and it will graph it for you, and you can double check and make sure it's what you were looking for. Okay, so hopefully that's helpful here. So examples 5 and 6 we are not going to actually draw. We are going to count instead. Okay, so we're going to go to example 5, which is 3, 7, and now we're going to get really tricky here. That's okay. I want to make it harder as we go. And -2, and you know what? Let's throw a really big wrench in this. Let's call it 1/2. So do you want to draw one more here? Maybe we should just draw one more because it's going to get a little bit iffy here. So we're going to go from 3, 7 to -2 and 1/2, which is going to be halfway between 0 and 1. So let's draw this one more time, and then example number 6 we'll just do with counting. So if you draw this out and you're counting squares so that you can do the Pythagorean theorem, it is 5 squares from here to here, and then it's actually going to be 6.5 squares from here to here, because you're going from 7 to 1/2. So there's a difference of 6.5 there. So that's where it's going to get really tricky. So 5 squared plus 6.5 squared equals c squared. Now you'd probably want a calculator at this point, because what you're going to get is 25 plus, and then you're going to get 42.25. So that's going to be 67.25. And that's going to be your c squared value. So that's not going to be terribly easy to work with. You're definitely going to want to have a calculator at some point. If you go 2 decimal places on this, you're going to find out that the distance was about 8.20. Now, midpoint, from 3 to -2, halfway between 3 and -2, add them and divide by 2, you get 0.5. Or 1/2 if you're into that. And then 7 plus 1/2 is 7.5. You cut that in half, and you get 3.75. So if you are a fraction person, that would be 1/2 here, and that would actually be 15 over 4. Your calculator will change it if you ever are asked to put it in the form of a fraction. All right, example 6. We'll do this last one, and this will be the one that we won't use our coordinate plane because we're getting spoiled here. So let's do 8, 7 because it wouldn't have fit anyway. So we'll just go with it. If we try the distance and we try it by counting, then we're just going to look from 8 to -1. How far would you have to go? Well, you count backwards. From -1 to 8, basically how far apart are they? And you're going to find out it's 9. From 7 to -5, you're going to find out that that would be 12. So we're going to set it up. 9 squared plus 12 squared equals c squared. This one without any coordinate plane, I wanted to make it a little bit easier. So you start adding it up. You find out you get 225. And then it turns out 225 is actually a perfect square. So it turns out the distance between these 2 points is 15. When it comes to the midpoint, again, I was telling you all along, you don't need to actually use a formula or anything. You can just add and divide by 2, and you didn't need a picture for that anyway. So 8 plus a negative 1 is 7. Cut that in half, you get 3.5. Add 7 and negative 5 together, you get 2. Half of 2 is 1. If you are a fraction person, remember 3.5 is the same as 7 over 2. All right. Hopefully that helped you out, and I'll talk to you next time.